Hello, Daisy. For the two problems that you provided, we use these equations. All of these equations are related to situations when an object is under a constant acceleration. The first equation allows us to calculate the final velocity by adding the initial velocity plus the acceleration times the time. If we accelerate the t, we get that time is equal to the final velocity minus the initial divided by the acceleration. Now to calculate the displacement, all we have to do is find the average between the final and the initial velocity, and then we multiply by the time. Same goes for distance, but this time instead of using velocity, we use speed. So we find the average of the speeds, the initial and the final, and then we multiply by the time. For the first problem, we have an astronaut that is jumping on the moon, and his initial velocity is 2.3 meters per second upwards, and the gravity of the moon creates an acceleration of negative 1.62 meters per second square. And they want to know what is the highest the astronaut jumps and what is the hang time. The hang time is whenever the astronaut falls back, lands back on the ground. Now, from this, we know that the initial velocity is 2.3 meters per second. The final velocity is 0 meters per second, and this happens whenever the astronaut is at the highest point of the jump. The acceleration is negative 1.62 meters per second square, and in order to determine the displacement, I need to know the time. So first, I can calculate the time because I know the initial and the final, and I know the acceleration. So I just plug in these values to my time equation. So it will be 0 minus 2.3 divided by negative 1.62, which ends up being about 1.42 seconds. Now that I know the time, and I also know the initial and the final, I can calculate the displacement. So it will be 0 plus 2.3 divided by 2 times the time, which is roughly about 1.63 meters up. So the highest that the astronaut jumps is 1.63 meters. Now, the hang time is just twice how long it took him to get to the highest. So all we have to do is 2 times how long it took him to get to the highest point, which is about 2.84 seconds, which is twice 1.42. For the second problem is someone going on a test drive. So initially, the person accelerates at 1.5 meters per second square from rest to 39 meters per second. After he reaches 39 meters per second, he steps on the brakes and comes to a complete stop after 2.5 seconds later. And they want to know what is the total distance traveled. In order to figure out this problem, we have to break it down into two parts. The first part is whenever we're speeding up. We're going from 0 meters per second to 39 meters per second, and the acceleration is 1.5 meters per second square. The second part is whenever we're slowing down from 39 meters per second to 0, and the time it took is 2.5 meters per second square. Here they want to know the distance, so I gotta use the distance formula. And I need to know the initial and the final and the time. For the second part, I know all those components. I know the initial, I know the final, and I know the time. So I can just plug it in to figure out the distance. So it will be the average between the speeds times the time. So 39 plus 0 over 2 times 2.5, it's about 48.75 meters. That's how much distance we travel while slowing down. Now, while speeding up, I don't know the time, so I have to figure out the time. And so I gotta use the time formula. And basically, I just do the final minus the initial divided by the acceleration, which I do here, which ends up being 26 seconds. Now that I know the time and I know the initial and the final speeds, I can use the distance formula. So I gotta find the average of the distances times the time. So I do 0 plus 39 divided by 2 times 26, which ends up being 507 meters. Now, all I gotta do is add these two distances to get the total time. So 507 plus 48.75 is equal to 555.75 meters total. And that's your answer. Hopefully this was useful. And if you have any questions about the steps that I took to solve these problems, you can go ahead and ask, and I'll reply back as soon as I can.